Hello everyone, welcome to the modern networking lecture series. This is lecture number 5 and in this particular lecture we'll study some more concepts which are required to properly understanding the requirements for networking. Okay, so the very first thing to do study is the types of networks and internet traffic. Now the traffic on the internet, it can be or any other traffic, or we can say enterprise networks, they can be divided into two broad categories. So whatever traffic, whatever data which is flowing through the networks, whether it is enterprise networks or the internet, it can be broadly classified into two types. One is the elastic traffic, other is the inelastic traffic. These are the types of traffic. So what is the meaning of elastic traffic? So in case of elastic traffic, this particular traffic, it adjusts itself over wide ranges with respect to changes in delay and throughput across an internet and still meet the needs of its applications. So this particular type of traffic, it can adjust itself. So if there is any delay or there is any throughput required, the data rate may change, okay, automatically, so that there is some adjustment. Okay, so the traditional traffic, whatever we see, the traditional type of traffic which is supported on TCP/IP is the elastic traffic. So the internet protocol which we are using, TCP/IP, it supports this particular elastic traffic. Now applications generating such traffic, that is the elastic traffic, they use TCP or UDP as the transport layer protocol. So at the transport layer we have either TCP or UDP, okay, although there is SCTP, but in this case we are considering this whatever applications which are at the application layer, whatever applications they are running, so they use the one which are the category of elastic traffic, they use TCP or UDP as the transport layer protocol. I can see this is the applications which use the which come under the category of elastic traffic. So we have FTP, file transfer protocol, secure SFTP, secure file transfer protocol. Then we have SMTP, okay, simple mail transfer protocol. Then Telnet, SSH, SNMT, and HTTP. So this can be classified as elastic. Now what are the requirements for this particular applications? Of course, different applications, they have different requirements. So the first is the email. Now email is generally insensitive to changes in delay. So if the email, if it reaches by different types of delays, then it won't affect the service. Okay, so this is insensitive to the changes in delay. While the file transfer is, when the file transfer is done through user command, the user expects the delay to be proportional to the file size and so is sensitive to changes in the throughput. Okay, so when the user is doing any file, using this file transfer protocol, doing the file transfer, and of course it is using through the user command, then the delay, okay, in that case the delay, so this service will be sensitive to the delay. Okay, so then delay is generally not a serious issue with network management protocols. Okay, so some, as we can see, some services they are sensitive to delay and some they are not sensitive to delay. Like we have interactive applications, so here they are sensitive to delay. Okay, more delay may hamper the service. Okay. Then we have inelastic traffic. Now what is this inelastic traffic? Inelastic traffic, it does not easily adapt to changes in delay and throughput across an internet. So they do not adapt. Like we have the examples of multimedia transmission or high volume interactive traffic. So this traffic, they come under the category of inelastic traffic. They do not easily adapt to the changes. Okay, whatever they're in that. So based on the traffic, varieties of delays can occur, or we may not get proper throughput. So these services, they may get affected because of this delays and throughput. Now the requirements for inelastic traffic may include this. The first is the throughput. Now in this case, in case of a throughput, a minimum throughput may be required. Okay, so if the throughput is below that, okay, then the service will not be delivered properly. Okay, so since many inelastic applications, they absolutely require a given minimum throughput. Okay, so the throughput must always be above that particular threshold. Then delay, which is also called as the latency. Now this is the time required for a packet to reach from source to destination. Okay, so we can have like those services which are affected by delay. Like we have an example like stock trading. Okay, the stock, the rate of the stock, they are changing every minutes. Okay, so if the delay is large, then there can be some loss to the customer maybe. And then we have delay jitter. Now delay jitter means what? Whenever a packet is when a source is sending some packets to the destination, if the packets are sent, like if we number the packets 1 2 3 4, but they arrive, because in case of IP protocol, the packets, they travel through different paths. So when they travel to different path, they arrive at the destination with different delays. So it may happen that packet number 1 was sent first, but it comes after 2 and 3. So that is called as the delay jitter. Okay, so the packets which are sent in sequence, they may arrive out of sequence. Then packet loss. Okay, packet loss means what? Maybe there may be some congestion in the network and packets have been dropped. Okay, so if maybe like 4 packets were sent but only 3 were received, so there are packet loss. Okay, so real-time application, they rely on the amount of loss of packets they can sustain. Okay, then we have the real-time traffic characteristics. So we have, in case of real-time means what? Like a live communication is going on. Okay, so in real-time applications are concerned with timing issues as well as the packet loss. Okay, they are this real-time applications, they are concerned with the timing issues, okay, as well as the packet loss. In most of the cases, there is a requirement that the data be delivered at a constant rate equal to the sending rate. Okay, if this rate is not maintained, then the data may not be received properly. Okay, so in other cases, the deadline is associated with each block of data such that data are not usable after the deadline is expired. Okay, so if the data, the packet is not reached within that particular deadline, then the data will not be of particular use. Okay, so here in this case, we have like we have a source and we can see there is a destination. Okay, and this packet, they are traveling. Okay, so here we can see this multimedia server is sending some data at a constant rate. It is generating a data at a constant rate. So here we can see the example is given that 160 data octets are sent every 20 milliseconds. But when they pass through the internet, they come out of it with unequal spacings. That is, they are unequally spaced. Okay, maybe like one packet may be lost. So here you can see 6 packets were sent, but here the packets, they are having uneven delays. Some packets arrive early, some packets arrive late. So you can see in this case the gaps are constant. Okay, so they have constant gaps, but here they are not having constant gaps, and one of the packet is also lost. Okay, so at the just before arriving at the destination, these packets, they are they are delayed, so that this the delayed in such a way that they arrive at the destination with the constant rate. Okay, like here 1 2 3 4, this one when arrives, okay, then 2 arrives. So this particular buffer, it gets the data, okay, gets the packet and then sends them through proper delay, so that they arrive with a constant rate. Okay, now here we can see that if one of the packet, it arrives after a deadline, okay, by the time the other packets have been already sent, so that if the time it arrives, that will not be of any use. Okay, now this is the real-time traffic types. These are the 3 types you can see. So the first is the continuous data source. So it is sending the data at a constant, so the data rate is also constant, okay, and the delay is also constant. Now the second one is the voice source with silent intervals. So you can see the data rate is same, but the time interval is different. Okay, and here the data rate is not constant, but they are sending at constant intervals. So these are the various types. Okay, so continuous data source, as we will see in this particular diagram. So these are the fixed size. So size of the packet is fixed, and they are also generated at fixed intervals. Okay, Then we have the second example of on-off source. Okay, so the source alternates between periods when fixed size packets are generated, fixed intervals, and period of inactivity. So here you can see that the packets are of same size, okay, but they may have some inactivity in the okay, that no packets are in that particular time period. Then variable packet size. So here the source generates the packets of variable size, but it generates the packet in uniform interval. Okay, now that was regarding the types of traffic. Now next we come to the contributors of the modern networking. We already covered this in previous, but we just something which are left. So this big data, cloud computing, and mobile traffic. We'll just see a brief review of this. So the application areas that are generating the greatest stress on the network resources and management are these three. Okay, these are the three application areas which have put enough pressure on the networking resources. Okay, and of course the management also becomes too much tedious. So these are the three application areas. The first is the big data, then we have the cloud computing, and we have the mobile traffic. Now all these areas, they need the use of powerful tools such as SDN, okay, and NFV. So we need some powerful tools. So this particular types of applications, they cannot be handled using the traditional networks. So we need to have some powerful tools. Now these are the powerful tools. That is, we have the software defined networking, SDN, and network functions virtualization, that is NFV, okay, for the network operation and management. Now using this, we get a comprehensive quality of service and quality of experience. Okay, so we start with the big data. Okay, now big data, what is big data? So big data refers to everything that enables an organization to create, manipulate, and manage very large data sets, which are of the order of terabytes, petabytes, and exabytes. Okay, and the facilities in which these are stored. So big data, it consists of tremendous amount of data, which is the data which is created, which is manipulated, and it has a large amount of data sets, okay, of the order of terabytes, petabytes, and exabytes. Okay, so they are large data sets. Now distributed data centers, data warehouses, and cloud-based storage are common aspects of today's enterprise networks. Okay, now factors which contributed the merging of big data and business networks. Okay, so these are some of the factors. The very first one is as we can see, continuing declines in the storage cost. So previously the storage media were expensive, now becoming cheap. Okay, then the maturation of data mining and business intelligent tools. Okay, then we have the government regulations and court cases that have caused to stockpile large masses of structured and unstructured data. Okay, so we need to store the data, maybe which can be used for further applications. Like, so we have documents, emails, and they have to be saved due to some regulations, government regulations. Okay, so they make up a tremendous amount of data. Okay, then we have other data sources which are being captured, transmitted, stored, including web logs, internet documents, internet search indexing. So many things are, so much data is generated and it has to be stored somewhere. Okay, then we have data sets continue to grow, with more and more being gathered by remote sensors, mobile devices, and we have this many sensors which are generating the traffic every day. Okay, every instance. And then we have cameras, and there are many such devices which with the number of devices are also growing and the traffic also growing. So it is estimated that 2.5 exabytes of data is created each day. So 2.5 to 10^18 bytes, this much amount of data is created every day. Okay, now regarding the big data infrastructure considerations. So traditional business data storage and management technologies, they include this relational database management systems. Then we have network attached storage, we have storage area networks, then data warehouses, then business intelligence analytics. So this big data applications, they are becoming a source of competitive value for businesses, especially for to build data products and services to profit from high volumes of data that they capture and store. So this is the big data networking example. Okay, here we can see we have some hosts, that these are the sensors which generate the data. Okay, then we have content delivery networks, then other enterprise data networks. Okay, so this is where we have the big data infrastructure. Okay, here we have various workstations, then we have blade servers, then network management servers, then data warehousing and enterprise networks. So this is the particular ecosystem of the big data, okay, which is connected to either, it can be connected through internet or maybe any private network. Okay, so these are the key elements within the enterprise which we have seen. The first, data warehouse. So data warehouse holds integrated data from multiple data sources which are used for reporting and data analysis. Then we have data management servers. So we have large bank of servers which serve multiple functions with respect to big data. Okay, they may be used to analyze the applications, data integration tools, etc. Then we have workstations and data processing systems. So these are the other systems which are used for big data applications, for generation of input to big data warehouses. Then we have network management server. So we have one or more servers which are responsible for network management, control and monitoring. So the networking environment for big data is very complex. Okay, the impact of big data is driven by the so-called 3 V's. Okay, the first is the volume, okay, which is growing amount of data. Then we have velocity, increasing speed in storing and reading the data. Then the third is variability, which is growing number of data types and sources. So these 3 V's, they are the impact of the big data on enterprising network infrastructure is driven by these 3 V's: the volume, velocity and the variability. Okay, then the areas of concern which with respect to this big data is, the first is the network capacity. So running big data analytics, it requires a lot amount of capacity. Okay, then latency, okay, that is what is called as a delay. So the real or near real time nature of big data demands a network architecture with consistent low latency to achieve optimal performance. So we want less amount of delay. Then again, the third is the storage capacity. Now in case of network capacity, because large amount of data is being shared, okay, so we must have a particular networking infrastructure so that can support that fast data. Then storage capacity is because massive amount of highly scalable storage are required. Okay, because daily, so as we can see, so much data is generated, so they have to be stored somewhere, so that we should have a very large capacity, storing capacity. Then processing. So big data, it adds significant pressure on computational, memory and storage systems. So because at a time large amount of data is generated, it has to be processed. Okay, so this requires high computation, large amount of memory and storage system. Okay, so if it is not properly addressed, then it can have a negative influence. Okay, so operational efficiency. Then we have secure data access. Okay, so big data projects, they combine sensitive information from many sources like customer transition, GPS coordinates, video streams. They must be protected from unauthorized access. Okay, so that's all for this particular session. Thanks for watching.